In the last episode, we wondered if the 3n+1 rule were a full-blown computer, one that could solve differential equations, compute pi, whatever. Nobody really knows. Every input we've ever tried goes to 1 pretty fast, so nobody's been able to compute too much with it. How about 5n+1 or 7n+1? Oh, that's a similar story. But in 1971, John Conway found another 3n+1 variation that can compute anything. The variation is sort of like this. Instead of asking whether n is even or odd, we ask what n's remainder is if we divide it by 6. So this gives us 6 cases instead of 2. Otherwise, it's the same as 3n+1. Let's see, so normally we have 18 goes to 9, 14, 7, 11, 17, and so on, up and down in a kind of unpredictable way. But with this 6-way system up here, 18 still goes to 9, then 14, and 7, but 7 goes to 2, and 2 goes to 1. So this system converges to 1 faster. Now this isn't Conway's variation. This is called the Farkas rule. And amazingly, unlike with 3n+1, all numbers go to 1 with the Farkas rule. It's been proven. Conway's variation looks like that, only bigger. And it can compute anything. It works like this. You write a program, coded up as a single large number. You hand that number to Conway's computer, and it runs the program. Even though the mechanism is pretty simple, it can solve advanced differential equations or do whatever you want. And Conway left a pretty good programming manual for it. It's kind of a weird computer, though. Anyway, the jury's still out on whether regular 3n+1 is a full-blown computer or not. If the 3n+1 conjecture is true and all numbers go to 1, it's probably not a computer, because every program marches down to 1 pretty quickly, leaving very little time for sophisticated computations. But if the conjecture is false, then you might be able to program 3n+1 to solve differential equations, or write poetry, or translate Swahili into English.